Ever wondered what Korea's national college entrance exam really looks like? A 3-point question. Less than 2 minutes. Let's go. This is considered hard. Number 18. Figure A shows how the star's brightness changes over time. Figure B shows the star's motion around the center of mass. The key is the line of sight. Everything we observe depends on motion along this direction. Which of the following statements about this data are correct? 3 points. No partial credit. Which of these statements are correct? One option tests the relationship between the transit and the line-of-sight velocity, one tests the meaning of the transit duration, and one tests whether the orbital period can be determined from the transit. First rule: don't rush. Take 20 seconds to read and identify what the problem is really asking. Between T2 and T4, the star moves away from the observer toward a zero line-of-sight velocity position, so its velocity is larger at T2 than at T4. At maximum dimming, the brightness is 0.9975. That tiny drop already tells us the size ratio between the planet and the star. From the brightness decrease, we find that the star's radius is about 20 times larger than the planet's. A transit starts when the front edge of the planet touches the star. It ends only when the back edge completely leaves, so the planet doesn't just cross the star's diameter. It crosses the star's diameter plus 1 planet diameter. That distance corresponds to 21 delta T. Here's a classic exam trick. The third option cannot be solved without the second one. A full orbit is. A transit graph is not just a change in brightness. It simultaneously reveals the planet's size and its orbital period. This is what Korea's CSAT really tests, and the correct answer is number 1.